هذا رئيس قسم المدني.
It is like your naked part of the body. It is exposed to rain, to snow, they spread salt. So it has a lot of corrosion, and then you have traffic, so direct impact of vehicles. So it ultimately leads to faster corrosion, cracking, what we call delamination. And so you need to inspect and rehabilitate those bridges. Currently, state DOTs, when they do inspection of bridges or bridge decks, they do it in two ways. The first way is that they visually inspect and mark maybe cracks. The second part, and that is when they are looking for problems. In most cases, they are looking for these delaminations, horizontal cracks. So how these cracks develop. When you have penetration of moisture and salts, that initiates corrosion of rebars, and corrosive products, they are worse than ice. They have very large volume, so they exert pressure and it causes cracking in concrete. So once you have a fairly large crack under the traffic loading, it is going to develop also vertical cracks, and you get a spall or pothole. So the inspection currently is done by visual inspection, and to find those delaminations, they are using a very, very simple way, and that is by dragging a chain. That is how it is being done today, to detect delaminations in bridge decks. There is some validity in the approach, but there are also a number of limitations. You typically detect problems with chain drag when the problem is in its latest stage. So you have no other option but to bring jackhammers, take that concrete out and pour a new one. So with this system we would do much finer diagnostics of bridge decks, because the robot is going to carry arrays of sensors. The first array of sensors is going to characterize corrosion. The second set of arrays, those are going to be acoustic sensors. They will detect delamination, and we will also use information to assess the quality of the concrete. And finally, it is going to carry ground-penetrating radar or GPR arrays. And those arrays we use for different purposes. For example, because it is GPR is excellent in detecting any metallic object in concrete. You can, for example, map rebars. You can also detect how much concrete cover you have. Even though, let's say, bridge decks are designed that those rebars should have at least 2.5 inches of concrete, when they are being constructed, you see everything from an inch to 4.5 inches. So they're not perfect, and it's reasonable to expect where you have less concrete cover that corrosion will start earlier. So GPR, we also know how to use it as to at least describe possible deterioration in bridge decks. So all of this information combined together with digital imaging, which will be done, images will be taken, which will be stitched, some processes which will do automatic crack detection will be conducted. So in a way, the robot is going to replace fully inspectors. And just to talk about production rate, maybe you saw some of the tools in the circle. These are what we generally call NDT, or non-destructive testing technologies. When we inspect the bridge decks today, we go with a team of 5 specialists which collect data. And our production rate is, and we are pretty good in what we do, is still only about 1,000 square feet per hour. So this is with a team of 5, with 5 different technologies. The robot itself will have production rate of about 10,000 square feet per hour, and you will need only a single person who is going to not operate but more control what the robot is doing. And the results will be of much higher precision, much higher resolution than what we do by using those, let's say, single sensor systems. So how the robot is going to move? it is going to move based on GPS coordinates. So the only thing what you will need to do is, let's say, find 4 coordinates or 4 points of the area you would like to survey. The program in the robot is going to interpolate, so how to move between different points. And the precision of this system is approximately, let's say, 3/4 of an inch. So, and once it is done, the robot will fold its sensors and move itself into a van and go to the next bridge.
Okay. Doctor, what's the weight of the robot?
It is about 700 pounds.
700 pounds?
Yes.
Okay, thank you.
So it's not light. And it's not light because it has batteries which can power it for about 6 hours.
Wow.
So it is going to have, so sometime in fall, it is going to have arrays of sensors on both sides. It is going to have cameras. It is even going to have a panoramic camera which is going to be on a pole, pneumatic pole, which will extend up to about 9 feet. So quite a lot of information will be collected.
Thank you.